So remind us again, what's got those scientists so excited?
Well, Gavin, it's all about neutrinos.
Now, that might have been recorded a few moments ago, possibly the way things are going. It was recorded tomorrow morning anyway. Make some sense out of this, I hope. I'm joined by the physicist and author, Dr. Michael Brooks. Michael, let's just assume that this research is right, on the right track.
Okay.
I mean, what could that mean in terms of the way we look at time and the question of which dimension we're in or may not be in?
Well, I think and it's a big assumption to say that it is true. I think the next recourse would be that these neutrinos are travelling through an extra dimension, which kind of sounds fantastical, but actually more advanced theories of physics that are currently being developed require us to have more than the 3 dimensions of space. And it's quite possible they took a kind of shortcut through a wormhole through space and arrived sooner than the light would in that way.
But is this some kind of Galileo moment when we're all going to start pulling out our hair because we realise we're not the centre of the universe, that things that we've held to be true for hundreds of years are suddenly not true, perhaps?
I think one of the problems that we have is that the Galileo moment always took place without the media speculation and the media storm. Now, physicists are being forced to come out with these, the rumours are leaking out, and so they're having to do this kind of analysis in public, which is somewhat embarrassing when it's quite likely and quite possible that they will find there's some kind of error, some kind of problem that they've just not taken account of yet.
Because measuring the speed of neutrinos is not something that, the police can do with their speed cameras. I mean, it's really, really complicated. So it could be wrong. It
could be wrong. There are sort of billions of neutrinos passing through your eye every second. They hardly interact with anything. So getting them to register on a detector is incredibly difficult. And then timing that register is very, very difficult.
But
again.
Is this largely a media get-up, or physicists are genuinely excited about this, aren't they?
Well, of course they are, because nothing in science really progresses without an anomaly, without something, that doesn't make sense to you, and you want to go and that's how we got relativity in the first place, because there was something wrong with the way charged particles emitted radiation. And so, yes, if it's right, then it's exciting, but physicists are very cautious, and most of them are saying there'll be something wrong with the experiment or the analysis.
But there are others, there's people writing like Michio Kaku and others who've been talking about all kinds of possibilities and questions of cause and effect, questions about basic philosophy, about how you actually decide to do a good action and whether you are responsible for your actions. I mean, all these questions could be raised by this, could they not?
Well, I mean, all these questions are raised by issues of time travel, but what we have is neutrinos, if they are travelling faster than light, there's no actual sort of indication that they necessarily carry information, which is the crucial thing. So they don't carry information from the future into the past, for instance. So it's too early to be saying, this is the route to time travel.
Very quickly, is this a bit inconvenient for a physicist, because you're going to have to rethink quite a lot?
I think they'll do the rethinking once the analysis has been proved right. I think, we can hold the presses on the new textbooks just now.
OK, Michael, thanks very much.